In this exercise, we deal with an extensive form game with imperfect information and nature, and we will provide its normal form and sequence form representations. Player 1 has 4 information sets, so her plans are made of 4 actions. The first action is played at information set 1.1 and it can be either action L1 or R1. The second action is played at information set 1.2, so it can be L2, C2 or R2. At information set 1.3, player 1 can play one between action L3 and action R3. Finally, at information set 1.4, player 1 action can be either L4 or R4. Conversely, player 2 has only 2 information sets, thus her plans are made of 2 actions. The first action is taken at information set 2.1 and it can be either L1 or R1, while the second action is either L2 or R2 for information set 2.2. These are all player plans. Let us construct payoff matrices. Say, for instance, player 1 plays plan L1, L2, L3, L4, and player 2 plays plan L1, L2. The outcomes that can be potentially reached are those corresponding to payoffs AB, QR, and XY, marked in yellow in the picture. The outcome that is actually reached depends on the result of the chance move made by nature at the beginning of the game. Specifically, payoffs AB are obtained with probability alpha, QR with probability beta, and XY with the remaining probability, that is 1 minus alpha minus beta. Therefore, we fill the matrix entry with player expected payoffs, where the expectation is made with respect to the chance move made by nature. Here, player 1 plays R2 instead of L2, while player 2 plays R2 instead of L2. Similarly to the previous case, player payoffs are AB with probability alpha, UV with probability beta, and XY in the remaining cases. Thus, we fill the matrix entry as in picture. In this case, player 1 plays plan R1, C2, L3, L4, and player 2 plays R1, L2. This leads to the expected payoffs in picture: IJ with probability alpha, ST with probability beta, and XY with the remaining probability. In this case, player 1 plays R1, R2, R3, R4, and player 2 plays R1, R2. The expected payoffs are OP with probability alpha, UV with probability beta, and XY with the remaining probability. As an exercise, you can try to fill the entire matrix. Let us switch to the sequence form. You can easily verify that these are player sequences. Let us build the sequence form payoff matrices. Say, for instance, both players play the empty sequence, that is, they never play. Then, the only outcome that can be reached is the one with payoffs XY, which is reached with probability 1 minus alpha minus beta as a possible realization of the chance move made by nature. We fill the matrix with player expected payoffs when they both play the empty sequence as in picture. Here, player 1 plays sequence L1, L3, and player 2 plays sequence L1. The two sequences define the outcome with payoffs AB, which is reached with probability alpha as effect of nature. These are the complete payoff matrices of the sequence form that I can build as an exercise. Now let us build sequence form constraints for player 1 realization plans. As usual, the empty sequence must be assigned probability equal to 1. At information set 1.1, the empty sequence enters while the sequences L1 and R1 exit. At information set 1.2, we have an analogous situation where sequences exiting the information set are L2, C2, and R2. At information set 1.3, sequence L1 enters and sequences L1, L3, and L1, R3 exit. Thus, the sum of probabilities assigned to L1, L3, and L1, R3 must be equal to the probability placed on sequence L1. And similarly for information set 1.4. These are the complete constraints in matrix notation. You can do the same for player 2 as an exercise.